So for the second half of 5.4, we're still looking at exponential growth and decay, but we're looking at a specific type of exponential growth and decay that has to do with what is called compound interest. Compound interest is when you put a certain amount of money into a bank, and then every year the bank's reward for you keeping your money with them is that you earn interest on it. So every year you earn a certain percentage of what you had previously. So that's exponential, right? Because you are taking 5% or 6% of the previous year and then adding it. However, different banks operate in different ways, or different stocks operate in different ways in the amount of time that they compound the interest. So, for example, in the problem that they gave, it said that if the interest was compounded quarterly, that means that every 4 times a year, they put the whatever percentage of the interest into your account. So even though throughout the whole year I'm earning 8%, it's getting put into my account in quarters. So in order to figure out what the actual rate of change is, we have to divide that 8% by 4. If I was putting the interest into my account biannually, how many times is it actually getting put in? Twice. So instead of dividing by 4, I would be dividing by 2. The other thing you have to pay attention to is that in this problem that they gave, we are compounding a 3-year period. But if I'm compounding the interest 4 times a year in those 3 years, how many times am I actually putting it into the account? 12. So that's where the 12 comes from. Okay? The generic form of an exponential is still exactly the same, a times b to the power of x. The only thing you have to make sure that in these types of problems you are thinking about is how many times am I actually multiplying b, and what is the rate that they gave me, which is why we divide, and then how many times am I actually multiplying that by for my exponent. Okay, so it's just interpreting the information that they give you and then still plugging it into the formula correctly. So we are going to do an example together, and you guys are going to do one on your own to make sure that we understand. So in the 3 examples, first of all, cross out example 6. We're not going to do it. Example 6 basically gives you a specialized formula for this. It really is exactly identical to an exponential function, except it gives you the specialized formula for it. You're doing the exact same thing, you just have to think about it. So instead of making you memorize like 3 different versions of the exact same formula, I want to teach you to just use your common sense to make sure you're plugging the same thing in every time. Okay? So in these exercises, you are going to identify a, b, and x. Then we're going to write the exponential function that models the situation. This means I want you to write the equation without anything plugged in for the variable. Okay, so you're going to write the equation without anything plugged in for x, because on your test, in an assignment that I'm going to give you today, I'm going to ask you for the function, just the generic function, before you plug any x's in. And then you're going to use that function to answer the equation. So then you're going to plug in x. Okay, so number 4, you invest $2,000 in an investment that earns 6% interest, but we are compounding it quarterly. So how many times a year are we compounding? 4. How much money will the investment be worth after 5 years? So let's identify what we know, and then we will plug it all in. A is my initial amount. How much am I investing initially, guys? 2,000. So A is 2,000. My B, the rate of change. Remember, with exponential growth and decay, this is a growth problem, so I'm adding what? 1. So it's going to be 1 plus 6%, which is 0.06. But I'm compounding it quarterly. So I'm getting 6% after the entire year is over, but I'm actually figuring out how much I get 4 times a year. So I have to divide the 6% by 4. Because the 6% is what I get total at the end of the year. Does that make sense? Yeah. So that's why we're dividing by 4, because the 6% is the total at the end of the year, but we're calculating how much we have 4 times a year. And then it wants us just to write, oh no, and then we need to figure out what x is. I am compounding, I want to know how much you have after 5 years, but I'm calculating every 4 times a year. So how many times will I actually be multiplying? 20. 5 times 4 gives me 20. So I want you to write the 5 times 4 just so you know how we got it. 5 years, 4 times a year is 20 times. Okay, so what's the equation? The equation is going to be y equals y equals 2,000 times 1 plus 0.06 divided by 4 to the power of x. Okay, so that's your equation. So on the test, on some of the homework problems, on the project you're going to get today, it asks you to write an equation that models the situation. That means this. There's nothing plugged in for x yet. You could simplify this. So using your calculator, remember you still follow order of operations. So you do 0.06, divided by 4, and then add 1 to that. So you could actually write your equation as 2,000 times 1.015 to the power of x. These are the same thing. And then to solve it, we want to plug in 20 for x. So y equals 2,000 times 1.015 to the power of 20. So remember, order of operations says we do exponents first. So 1.015 to the power of 20 gives me this huge decimal. Do not round until the very, very, very end. So in second period, I actually had some people do that. So I had one person not round and one person round in the middle of the problem. Their answer differed by like $4, which is pretty significant when you're trying to figure out an exact amount, okay? So do not round until the very end. So what you do is you leave this whole big number in the calculator, and then you multiply by 2,000. So we should end up with $2,693.71 at the end of 5 years. So it should be exactly what's in your account at the end of 5 years. So what I want you guys to do is try problem 5. In problem 5, you're compounding monthly. So how many times are you actually compounding in 1 year? 12, okay? So do number 5, follow exactly what I did in number 4. Since we're skipping 6, you can do all your work below. I know it's a little squished, but just make do. So number 5 says that you invest $3,000 in an investment that earns 5% interest compounded monthly. How much will the investment be worth after 8 years? So I'm going to do number 5 down here. A is equal to what?
3,000.
3,000. B is equal to
1 plus
0.05 divided by what? 12. Okay, and then X is equal to 12 times 8, which comes out to 96. So the first step is to write an equation for that. So y equals 3,000 times 1 plus 0.5 divided by 12. So I'm going to do 0.05 divided by 12 plus 1. So I'm going to say 1.004.
I rounded it there and got a different answer.
1.004 to the x. So even though I rounded it right here, when I punch everything into the calculator, I'm going to leave it this big long thing, okay? So that's going to, we're looking for x is 96. So 3,000 times 1.004 to the 96. So I'm going to take this giant number that I got, raise it to the 96th power, and then I get this. And then I'm going to multiply by 3,000. So you should have got $4,471.76. Okay, so really quick. If I am compounding annually, what am I dividing by? Annually means? 1. So if I'm compounding annually, do I really have to show that I'm dividing by anything? No, because it's just 1. Okay? Same with the exponent. Okay? So we're just giving you an example of what happens if we compound more than annually. If it's compounded annually, it's exactly what we've been doing this whole time. Okay? That's the rest of 5-4.